Yes, we made it. Polar EQs. We're going to change this into XY equations. And then you don't got to listen to me rant and rave anymore. Huh? Well, actually, maybe one more time in class. Maybe you watch this after class. Then you don't got to listen to me talk anymore. How nice is that? No more rambling crazy dude, huh? Okay. Let's go convert some polar equations into rectangular. Let's start with the first one. We got to do the old classic. We got that r is equal to 5. You know what? It might be easier to do this. We got a couple choices here. When we do these, we can typically either square both sides of the equation or we can give it an r. That's usually the game. So let's write that. We can square both sides. Typically, when we're doing this, or give it an r. Give it an r on both sides. I should say multiply, but you know what I'm saying. So on this one, I'm thinking squaring both sides because we want to create, our typicals. Isn't r squared equal to x squared plus y squared? It is. So it'd be a little simpler. I don't want to write the square root of x squared plus y squared equals 5. I'd rather square both sides of this sucker. And we find out that we get r squared is equal to 25. Now we can go and sub in, and we're like x squared plus y squared is equal to 25. And there's our solution. It's like, hey, imagine that. The radius is 5, and we don't give a shit about the angle. It can be all the angles. That's called a circle. It's just describing a circle. So when it says r is equal to a number, you're describing a circle coming out of the origin. Cool. Let's go to this one. Let's go into it. Let's start getting weird. Let's say r is equal to, let's say it's equal to 4 times sine of theta. Now this is one of my favorite ones. I like these. So we got a choice. We can either square both sides, or we can give it an r on both sides. More often than not, you're just going to give it an r on both sides. Because what we want to create, all I see is a sine theta. We have no conversions for sine of theta. But r sine of theta, well, that's equal to y. And r cosine of theta, that's equal to x. So the game is we're trying to make pictures that we can convert. It's like a puzzle. Just a puzzle. So we want to find something. So we're like, dude, let's give it an r on both sides. So we're like, all right, let's give it another r, so that becomes r squared. And then we go 4 times. And we want to put the r in a very special spot. We want to put it right there, right next to the sine of theta, so then we can see it. And we're like, I got this shit. I got this shit. R squared is x squared plus y squared. And 4 times. And then r sine of theta, well, that's equal to y. Well, oh shit, do you know what this is? X squared plus y squared is equal to 4y. Did you know that that's a circle? Did you know that that is a circle with a radius of 2? I hate to do it to you, but here it comes. If we were to want to plot this, a little bit of a lead into what I'm going to talk to you all about on what was it, Monday or Wednesday, maybe. We're going to do one of these. And then we're going to complete the square. Just right here. We're looking at this. Because our general form of a circle, because this is a circle, is x minus h squared plus y minus k all squared is equal to r squared. You already knew that, right? Where the center is at h comma k. You already knew that, right? I mean, you wouldn't make it to trigonometry not knowing anything about circles in the whatever the 10 years you spent learning about math. I imagine a lot of us forgot it, but hopefully that's something you're like, oh, okay, I think I've seen that shit before. So while we already have our x minus 0 all squared, it's right here, our x minus 0 all squared. We don't have our y minus something. There's 2 y's there, so we're going to have to complete the square. So we look at our b, that's negative 4, and we cut it in half, and we get negative 2. And then we square. So b over 2 all squared is equal to 4. So we'll give it a 4, and we'll give it a 4. That's how you complete the square. Now what that's done for us is it's gone like this, x squared. And now we've created a perfect square from right here. This is y minus 2 all squared. Hence, this is a circle with its center at 0, 2 and a radius of 2. This is r squared. It looks something like this, where there's the center, and it has a radius of 2, so it actually touches the origin. Huh, neat! A freaking circle. So when you see things of this form, r is equal to a number times sine or cosine, that's a circle. It's just not centered at the origin. And there might be some sort of trick. I'm wondering, just ask you real fast, how long do you think the diameter of this is? How long do you think the diameter of that circle is with a radius of 2? What do you think it is? What do you think? Do you think it's 4? Do you think the diameter is 4? And now does sine go with y or x? Doesn't sine go with y? Huh, weird, it's on the y-axis. I wonder what happened if it was negative. Moving forward, let's go to another problem, and I think we can pretty much wrap it up right here. Let's say r is equal to, let's make it 1 over 1 minus cosine of theta. Actually, I don't want to do that one. That one sucks. Let's do this one instead. I don't want to do that one. I'm sorry. Let's change this thing up. Let's call it 5. Let's get weird. Sine of theta. And let's go minus 4 cosine of theta. Now you've seen this one already. Just go in the other direction. Here we be. You don't solve for variables in the denominator. So when you see this, you go immediately like, no, I want you out of the damn denominator. So you're going to multiply both sides of this by sine of theta minus 4 cosine of theta. All right, both sides. You don't have to write this. I'm just being long-winded because I know it's weird to look at this algebra. So that shit can cancel out and just leave you with your 5 on this side. And now we'll have our r times, there it is, r sine of theta minus 4 cosine of theta. So that's that game. You got to pop that thing out of the denominator. Now let's bring this shit in, because we don't have anything for sines of theta. We don't have anything for cosines of theta, but we sure as hell have things for r sine of theta minus 4 times. We put the r next to the cosine. R cosine of theta is equal to 5. Well, shit, howdy. Let's do it. R sine of theta is just equal to y. R cosine of theta, well, shit, that's just equal to x. And that's all equal to 5. Hence, you have the line y is equal to 4x plus 5. And there it is. There's conversions. There's going back and forth. We dicked around. You need to be able to go from equation to equation. There is a big freaking reason why you want to know this. You don't ever really have to know this. You just get slapped on the hand the whole way through until you get into your calculus classes. Or then it's going to be up to you. And you don't have to. You can go and do the 100 steps it's going to take to do it in x's and y's, while your buddy next to you does it in 2 steps with r's and thetas. This is going to make your life easier down the road, not right now. Right now, you get to understand it. But in the end, it's going to be something that hooks you up, not brings you down. It's going to be a shortcut. So if you are continuing on the calculus path, you will need to know this. If you're going into physics, maybe not so much, but either way, I'm done babbling at y'all. I'll see you in class.